Hi, welcome back to our Rising SSR channel. This is continues to our previous video part 1. If you missed part 1 video, please go through link mentioned in description for first 4 modules, and in this video we are discussing remaining 4 modules. Please watch entire video and don't forget to subscribe. Thank you.
Constantly keeps on monitoring the associated systems. When you run your production, it becomes easy because let us say that you have configured Dynatrace in your pre-production environment. You have tested it thoroughly since past 5-10 releases. So by the end of 10th release, you have a particular configuration of Dynatrace in your pre-prod. You just need to copy paste the same configuration into prod, right? So 99.9% you will be confident that yes, I have done a thorough testing until my pre-prod, and with that thorough testing, this is the configuration of Dynatrace that helped me. Can I have the same configuration in my production environment, right? And I'm not saying that, and that is why I say 99.9%. There can be some unique, very peculiar problems that is identified only in production, because the production environment traffic transactional footprint, the volumetric footprint is uh, a bit different. However, best you try to simulate in pre-production, you cannot do that. No testing team can do that. No test engineer can do that. You can mimic near to production, but the actual production usage, the actual production footprint for transactions or user concurrency is unique in nature. Right, there will be 0.1, 0.001, or whatever. There will be certain difference. So maybe in production, your monitoring tool identifies something very unique, right? Which is good. Which is good. So these are the tools. I mean, we talked about Nagios, Dynatrace, App Dynamics, Prometheus. From a logging perspective or security incident event management perspective, most of the organization uses a Splunk and Logstash. Uh, right. Talking about future growth, and again, I'll share a few live examples here. We briefly touch based on the importance of non-functional testing, right, and why it is important, right? So, from a perspective of, and we all have experienced it in last 2 years. I don't know whether you experienced this problem in India or not, but in the UK, I can see that when the COVID situation kicked off, right? The initial COVID situation, and there was severe lockdown, right? Nothing happening. Then people used to rely more on online shopping, even for groceries. Okay. And unfortunately, none of the retailers have built in their system for such a huge traffic. They never ever anticipated that their systems are going to deal with so much of traffic. So because of that, their infrastructure was not able to cope up. Their application code was not able to scale. And initial few weeks, there were so many news on internet, so much of news that uh, every 10 minutes, half an hour, some retailer's website was crashing, failing, crashing, failing, right? Uh, and the reason was there was no thought process built in to ensure that how the system should cope up in a entirely adverse situation. And they cannot re-engineer the application overnight in a week, right? No company can do that. It takes years and years and years to design, build, and architect a resilient system. So the only option they had was they limited the traffic. Let's say that They know that yeah, application can deal with only 500 concurrent users. So they set up a firewall rule, right? That firewall rule is used to track the number of incoming requests. So if there are more than 500 users, if I'm trying to log in, they will put me into a queue, right? So that I do not enter into their system, and that doesn't allow their system to crash. So once one user is done and he leaves the system, then the next user in the queue will enter the system. That is how they introduced a temporary solution. Okay. And that is a very important case study when we are talking about future growth. So when we talk about SRE, it's not only testing for, let us say that my non-functional requirement is to test with a peak of 100 concurrent users with 1000 transactions per second. Obviously, that is there. I have to test that, but I need to have that vision, that wisdom, not only to limit my test with 100 concurrent users and 1000 transactions. I need to educate the business that what if more than 100, let us say, what if 200 concurrent users are logging into the system in the peak hour? What if more than 1000 if we are get per hour? Right? We need to design, we need to build, we need to test the system for certain things which is unanticipated. And we need to design, build, and build our infrastructure as well for those unanticipated things. And until and unless we do not think about those scalability aspects, right? So that's the worst case aspect. In a normal world as well, right? Every business anticipates a growth. So if I am having 10 customers today, maybe every month I am going to have an addition of 10%, right? So I need to ensure that I build my system, test my system for the future growth, at least for the next 5 to 10 years. And that is called as a scalability. As my user pattern is increasing, as my volume pattern is increasing, is my application code scalable as well? So there are two aspects. When we talk about scalability, it is not only the scalability of infrastructure, right? Your infrastructure, you can scale it. You can add servers, you can do a horizontal scaling or a vertical scaling to eliminate the infrastructure bottleneck. But what if your application code itself is not scaling, right? The way the code is written, the way the code is configured, if it is not scaling beyond a particular throughput, beyond a particular number of users, then there is a problem. So all these things have to be thought right from the very beginning. All right. So there's a concept. I mean, most of the companies say that okay, we are leveraging cloud. We need cloud provides auto scaling. I don't need to worry about um, how do I scale my infrastructure because cloud will automatically take care of. Yes, that is right. Cloud automatically takes care of, but we need to build that level of intelligence in the cloud. So, any of you who have worked on any of the cloud, right? Uh, Auto scaling is a concept, but auto scaling doesn't work in itself. You need to infuse that level of intelligence to the cloud. You need to say that, okay, cloud, I have my application deployed on a EC2 instance. The EC2 instance is having, let's say, 5 CPU and 5 gig of memory. So until and unless you have not done a thorough performance testing on one particular EC2 instance, you will not know that how much volume it is able to cope up. So let us say that it copes up 100 users, and after 100 users, we can see that the CPU and the memory starts shooting up beyond 90%. So you know that yes, one of my EC2 instance can handle this much of volume. So you can configure auto scaling policy, and that auto scaling policy can be as soon as the EC2 instance senses. And that is done. I mean, in AWS, you have a component called as CloudWatch. So as soon as CloudWatch senses that for that EC2 instance, right, there is 100 concurrent users, or you can set up or uh, condition that as soon as CPU memory goes beyond 60, 80, 90%, when you know that failures will start occurring, before the failures start occurring, trigger this auto scaling policy. It will create another server for you. It will deploy another. I mean, it's a replica of your EC2 instance, right? So what I'm trying to say here is that auto scaling obviously is an amazing thing, but for it to work, there needs to be a lot of testing, lot of thorough testing for various permutation and combination. Then only you will be in a position to infuse that uh, best protocol into your auto scaling policy. Otherwise, it is not going to be possible.
Ankit, Srini here. So, what is EC?
Sorry.
What is EC stands for?
EC, okay. EC2 is when you have to create a server on Amazon Cloud, AWS, right? Then it is that unit of one unit of server is called as EC2. Okay,
Okay. Mhm.
EC2 is exactly.
Virtual compute instances.
Are you talking about IBM Private Cloud?
Now, I'm talking about our bank cloud.
Hmm.
So, one VC is basically call it as 4 vCPU and 8 GB
Yeah,
memory.
yeah, you're right. I mean, different cloud vendors call it in their own way. So EC2, Amazon calls it as EC2, and E stands for Elastic Compute. EC2, Elastic Compute Cloud. That is the full form. When you see the same thing in Google, they call it as Compute Engine,
Mm.
CE.
Mm.
Okay, so different cloud uses different nomenclature, but at the end of the day, it is nothing but it is creating a infrastructure, a server for you, and you can instruct. They
Yeah.
have a lot of predefined images. You can
It's
create yeah, you can create a Windows server with X amount of CPU, X amount of memory, right?
Mhm.
So once you log into the EC2 or the AWS console, and let us say that if you want to create a Windows server, right, select that, and then you can see it displays you hundreds and hundreds of options. What do you want? You have got right from the very minimal infrastructure, a small tiny server, to a very gigantic server, right? So if you log in, it will display you all the options. You just need to say that you want, let us say, a Microsoft server with Microsoft operating system and SQL Server installed, IIS Server installed. You just need to select the uh, hardware and the software stack. Once you do that selection, then it will display you all the options together with the cost. And then that will give you an insight, okay, depending on what your budget is, what your organization budget is, what exactly you want to select. And it's not only the budget aspect, it is what exactly the business objective. If you are building let us say a high transactional system, then obviously you need a very powerful robust server. But if you are just building a normal online application for internal use, then you don't need. So it depends on the business objective, and all these planning on what exactly you need is predetermined. So you have done an exhaustive analysis, and once you are done, then you just go ahead and choose the appropriate option using whatever cloud it is. So to answer your
Understood.
question, yeah.
It's basically a unit of measurement, right?
That is right.
Mm.
It's not a unit of measurement. It is basically a service offering. So if you want to create infrastructure as a code in AWS, they provide you with the EC2 service offering, which is Elastic Compute uh, Cloud service offering. When you want to create that into Google, Google provides you with a compute engine service offering. So it is the name of the service offering.
Okay.
Now we are going to talk about a very important concept which is called as anti-fragility. Any of you have heard about this before? Anti-fragility? Or if you have not heard about anti-fragility, at least can you tell me what is your understanding? What do you mean by anti-fragility?
Fragility is to break, so I presume like it's something like to prevent the break or something like that.
That is right. You're spot on. Thank you. So, um, yes, fragile is anything that
సిరి
that
పాప
is
మెట్టల
break.
పాప పాపలు
Glass is
వస్తున్నాయి
fragile, right? Because it
అట్లా
breaks
వస్తున్నాయి అంతే
when you put some stress, when it falls
నువ్వు
down.
చెప్తా ఇది పెట్టుకో చెప్తారు అదంతే వెన్నెల కాదు సిరి
When
కాదు
we talk in terms of IT components, IT applications, when we talk in terms of uh, IT systems, what can break? There are only two things that can break. Either the
వస్తాయి
infrastructure
తర్వాత
can break or the
తర్వాత
application
వస్తాయి రా
code
బ్రదర్
can break.
రవి
Anything other than these
ఇప్పుడు
two
రేపు
that you can
ఎనిమల్స్
think of
వస్తున్నాయి
which
ఇప్పుడు
can break? No.
ఏ
Certain
వచ్చినాయి
implicit things, for example, when we talk about infrastructure, when we talk about code, yeah, they can break, and the associated configurations, which is implicit.
Security as a it
Sorry?
could be broken. Security could be broken.
I mean, that is what I am saying. Security is also baked into it, is inbuilt, right? So we implement security at an infrastructure level, we implement security at a code level, right? So if the infrastructure is broken or the code is broken, obviously the security aspects will also be broken, right? So yes, I mean, we can talk about breaking a lot of things, breaking the security aspects, breaking the usability aspects, breaking the reliability aspects, but all these aspects that we can think of, all the parameters that we can think of, at the end of the day, at the bottom of it is nothing but the code and the infrastructure and the associated configuration. So SRE talks about how do we build in anti-fragility into our application code and into our infrastructure. Building in anti-fragility is very much needed. Gone are the days. I mean, uh, not more than 5 years or 10 years, right? Right. Even if we want, we are not in a position to dynamically do anything. But now the objective is that how we need to architect anti-fragility into our code and infrastructure, right? And it is relatively easy now because of the technological advancement that cloud provides us, because of the architectural advancement that we have from a microservice based architecture, right? Earlier we had monolithic architecture, and because of the monolithic architecture there were limitations on resilience, scalability, but as a part of microservice based architecture we don't have
అయిపోయినాయి
that. Now how do we do that? Let us say that um, um, I have to build a microservice, and we talked yesterday that microservices are always deployed on a container, right? Okay, I mean, before I go ahead, do you have at least a high level understanding of what a container and what a Kubernetes is? Any of you?
Little awareness I have.
Sorry.
I'm aware of it, but not fully, but I can
Okay.
understand.
All right. So looks like other participants are not. So we talked about yesterday, right? We talked about the evolution from physical to virtual to container architecture, right? So basically, uh, container is nothing, but it is a abstracted layer. You can have a play around it. You can download a Docker container. You can download a Docker software, and using Docker, you can create containers. So container is basically, if you have to understand it in an easy way, uh, it varies on, I mean, you have a different container. If you want for a Microsoft operating system, you need to have a different container for various flavors of your Unix operating system. You can use Linux, you can use Ubuntu. So for the respective uh, Unix flavor, you have got respective containers. So the thing is, um, Docker is dominating in the market when we talk about containers, right? So we deploy our microservices. Let us say that I have created a microservices using Node.js, or I have created a microservice using .NET Core. So once I write the microservice, obviously I need to deploy it somewhere, right? And if I want to deploy it, I do not have uh, options other than deploying it in a container. So Docker tells you that, okay, you don't need to worry about, I can create container for you, and you can deploy your microservice. I will run it for you. Okay, great, Docker. Thank you very much. But the thing is, Docker tells you this, but how are you building in anti-fragility? If you are deploying your microservice into just one container, are you building anti-fragility? If your one container dies, what will happen? Your application goes for a toss, right? So just listen to me what I'm telling very clearly. It will really be an eye opener for you. Okay, then you say that, fine. Let me have two containers. No problem. Even if my one container dies, I have my other container, which will deal with the incoming traffic. Very good. So you are at least building that level of resiliency at a container level. No problem at all. But those of you who know cloud, right? Let us stop the container discussion here. Let us go to cloud architecting. In cloud, you have a concept of region. Region is nothing that, let us say, uh, I want AWS infrastructure to be built. So at the very top, AWS asks me, where do you want your infrastructure? I have Asia Pacific region. I have EU region 1, Asia Pacific region 1. I have got uh, US region 1, 2, 2, 2, 3, and number of regions. Then you say that, okay, I want it in Asia Pacific West. Then within Asia Pacific West region, you have got multiple availability zones, which we call it as AZ or AZ. Availability zone is again different geographical locations. So maybe you will have, Amazon will have one uh, data center
అంతే
in
అట్లా వచ్చినాయి
Singapore,
అంతే
one data
వాటర్
center
మంచిగా ఉంటుంది
in
అప్పుడప్పుడు తాగితే
Malaysia, another
అంతే
data center in Mumbai, another data center in Delhi. So these are four different availability zones within Asia Pacific region 1. So far it is clear. So you have got region at the top, and below the region you have got multiple availability zones, right? Now, let us say that I have this Docker container and I deploy the Docker container in Mumbai availability zone. My code is running on the container in Mumbai availability zone. I have two containers running, right? And I'm ensuring that my one container goes down, my other container will still be up and running. But that's not enough. What will happen if the Mumbai availability zone goes for a toss? If flooding starts in Mumbai and that data center is flooded, what will happen? Right? Your dual container strategy is not going to help you. So that is the reason you need to think out of the box. You need to ensure that you have your containers running across all the availability zones. So that one availability zone goes down, you have other availability zone to take care of. Other goes down. In that case, you are building anti-fragile strategy for your application code as well as your infrastructure. But you may want to ask this question that, okay, what if the entire region goes down? It happens. It happens. It's not something which is every 5 months, 6 months, 2 months, 3 months, you can hear this news. Sometimes AWS entire one region goes down. Sometimes Google one region goes down, right? So that is where your multi-region strategy comes into picture. And bear in mind, all these things are costly, expensive. So everything comes at a cost, right? We all know that. If we really need to build in a very highly reliable system, it is not uh, cheap. It comes at a cost. But it depends on what the organization wants. What are the organizational priorities? So we are trying to, first of all, mitigate risk at a region level. So within a region, I have got 4 availability zones. I ensure that my code is up and running on all the 4 availability zones. I ensure that it is properly load balanced, right? I ensure that uh, if anything goes wrong in any of the availability zones, right, then cloud automatically takes care of it. I mean, that is the
Eat it.
beauty of cloud as well as the beauty of containers. If a container crashes, then you don't need to worry about it. Automatically, it will spin off in next few seconds or few minutes. Sorry. So that is where anti-fragile architecting approach comes into picture. But again, I wanted to tell you, if you are just creating 2, 3, 4 microservices, 10, 15, 20 containers, then Docker is telling you, don't worry, I will take care of. But if you are talking about hundreds and thousands of containers, hundreds and hundreds of microservices, that is where this gentleman Kubernetes comes into picture. Right? It is an orchestration tool. It will tell you, okay, you don't need to worry. Even if you want hundreds, thousands, millions of containers creation, I will take care of that right from its birth until its death. So Kubernetes is an orchestration tool, right? And when you have to implement things at a scale, you can use Kubernetes. So it takes care of anything and everything, right? Right from birth, as I said. So what things it takes care of? You can instruct Kubernetes to spin off containers. You can tell what is no
Yeah,
certain
listening.
implicit things. For example, when we talk about infrastructure, when we talk about code, yeah, they can break, and the associated configurations, which is implicit.
Security as a security
Sorry?
could be broken. Security could be broken.
I mean, that is what I am saying. Security is also baked into it, is inbuilt, right? So we implement security at an infrastructure level, we implement security at a code level, right? So if the infrastructure is broken or the code is broken, obviously the security aspects will also be broken, right? So yes, I mean, we can talk about breaking a lot of things, breaking the security aspects, breaking the usability aspects, breaking the reliability aspects, but all these aspects that we can think of, all the parameters that we can think of, at the end of the day, at the bottom of it is nothing but the code and the infrastructure and the associated configuration. So SRE talks about uh, how do we build in anti-fragility into our application code and into our infrastructure. Building in anti-fragility is very much needed. Gone are the days. I mean, uh, not more than 5 years or 10 years, right? When we used to have a microservice based architecture, right? Earlier we had monolithic architecture, and because of the monolithic architecture, there were limitations on resilience, scalability, but as a part of microservice based architecture, we don't have that. Now, how do we do that? Let us say that um, um I have to build a microservice. And we talked yesterday that microservices are always uh, uh, deployed on a container. Right. Okay. I mean, before I go ahead, do you have at least a high-level understanding of what a container and what a Kubernetes is? Any of you?
Little awareness I have.
Sorry.
I'm aware of it, but not fully. But I can
Okay.
understand.
All right. So looks like other participants are not. So we talked about yesterday, right? We talked about the evolution from physical to virtual to container architecture, right? So basically, uh, container is nothing, but it is a abstracted layer. You can have a play around it. You can download a Docker container. You can download a Docker software, and using Docker, you can create containers. So container is basically, if you have to understand it in an easy way, uh, it varies on, I mean, you have a different container. If you want for a Microsoft operating system, you need to have a different container for various flavors of your Unix operating system. You can use Linux, you can use Ubuntu. So for the respective uh, Unix flavor, you have got respective containers. So the thing is, um, Docker is dominating in the market when we talk about containers, right? So uh, we deploy our microservices. Let us say that I have created a microservices using Node.js, or I have created a microservice using .NET Core. So once I write the microservice, obviously I need to deploy it somewhere, right? And if I want to deploy it, I do not have uh, options other than deploying it in a container. So Docker tells you that, okay, you don't need to worry about, I can create container for you, and you can deploy your microservice. I will run it for you. Okay, great, Docker. Thank you very much. But the thing is, Docker tells you this, but how are you building in anti-fragility? If you are deploying your microservice into just one container, are you building anti-fragility? If your one container dies, what will happen? Your application goes for a toss, right? So just listen to me what I'm telling very clearly. It will really be an eye opener for you. Okay, then you say that fine. Let me have two containers. No problem. Even if my one container dies, I have my other container which will deal with the incoming traffic. Very good. So you are at least building that level of resiliency at a container level. No problem at all. But those of you who know cloud, right? Let us stop the container discussion here. Let us go to cloud architecting. In cloud, you have a concept of region. Region is nothing that, let us say, uh, I want AWS infrastructure to be built. So at the very top, AWS asks me, where do you want your infrastructure? I have Asia Pacific region. I have EU region 1, Asia Pacific region 1. I have got uh, US region 1, 2, 2, 2, 3, and number of regions. Then you say that, okay, I want it in Asia Pacific West. Then within Asia Pacific West region, you have got multiple availability zones, which we call it as AZ or AZ. Availability zone is again different geographical locations. So maybe you will have Amazon will have one data center in Singapore, one data center in Malaysia, another data center in Mumbai, another data center in Delhi. So these are four different availability zones within Asia Pacific region 1. So far it is clear. So you have got region at the top, and below the region you have got multiple availability zones, right? Now let us say that I have this Docker container and I deploy the Docker container in Mumbai availability zone. My code is running on the container in Mumbai availability zone. I have two containers running, right? And I'm ensuring that my one container goes down, my other container will still be up and running. But that's not enough. What will happen if the Mumbai availability zone goes for a toss? If flooding starts in Mumbai and that data center is flooded, what will happen? Right? Your dual container strategy is not going to help you. So that is the reason you need to think out of the box. You need to ensure that you have your containers running across all the availability zones. So that one availability zone goes down, you have other availability zone to take care of. Other goes down. In that case, you are building anti-fragile strategy for your application code as well as your infrastructure. But you may want to ask this question that, okay, what if the entire region goes down? It happens. It happens. It's not something which is every 5 months, 6 months, 2 months, 3 months, you can hear this news. Sometimes AWS entire one region goes down. Sometimes Google one region goes down, right? So that is where your multi-region strategy comes into picture. And bear in mind, all these things are costly, expensive. So everything comes at a cost, right? We all know that. If we really need to build in a very highly reliable system, it is not uh, cheap. It comes at a cost. But it depends on what the organization wants. What are the organizational priorities? So we are trying to, first of all, mitigate risk at a region level. So within a region, I have got 4 availability zones. I ensure that my code is up and running on all the 4 availability zones. I ensure that it is properly load balanced, right? I ensure that uh, if anything goes wrong in any of the availability zones, right, then cloud automatically takes care of it. I mean, that is the
Eat it.
beauty of cloud as well as the beauty of containers. If a container crashes, then you don't need to worry about it. Automatically, it will spin off in next few seconds or few minutes. Sorry. So that is where anti-fragile architecting approach comes into picture. But again, I wanted to tell you, if you are just creating 2, 3, 4 microservices, 10, 15, 20 containers, then Docker is telling you, don't worry, I will take care of. But if you are talking about hundreds and thousands of containers, hundreds and hundreds of microservices, that is where this gentleman Kubernetes comes into picture. Right? It is an orchestration tool. It will tell you, okay, you don't need to worry. Even if you want hundreds, thousands, millions of containers creation, I will take care of that right from its birth until its death. So Kubernetes is an orchestration tool, right? And when you have to implement things at a scale, you can use Kubernetes. So it takes care of anything and everything, right? Right from birth, as I said. So what things it takes care of? You can instruct Kubernetes to spin off containers. You can tell what is the size of the container that you want, right? You can monitor containers using Kubernetes inbuilt monitoring, right? You There is a bit of similarity and a lot of dissimilarity. So traditionally, right, uh, we had DRS strategy, and it's not traditional now. Now as well, we have DRS strategy. But how are we building our DRS strategy? So if you see the on-prem implementation of a DRS strategy, then on-prem implementation doesn't give you that flexibility of uh, increasing, decreasing the capacity sizing depending on the traffic, right? So you have, let us say, 5 servers on site 1. You have the same 5 servers on site 2. So if your application is running hot,
Finish.
then you don't need to worry about, I mean, even if site 1 goes down, your site 2 is there, which is already running. It will take care of the traffic, right? But the thing is that as of now, your application has been designed to run hot, right? So let us say that uh, your peak volume is 100 transactions. 50 transaction is coming to site 1, 50 transaction is coming to site 2, right? It's load balanced. But in a DR situation, when your site 1 goes down, means all the 100 transactions will go to site 2. Hmm? Have you built in that anti-fragility into site 2 so that in the worst case, if 100 transactions comes to site 2, user experience is not compromised? If you have built that in, well and good. Have you thought of that in the worst case, you can even experience more than 100? It may be that 200, 300 transactions also. Have you designed your site to cater to that? If you have designed, you have built in anti-fragility. But traditionally, most of the companies, they, they never thought about it, right? But if you have designed, architected your infrastructure to at least deal with the worst, then yes, even on-prem, you have designed anti-fragility by ensuring that you have adequate capacity, adequate infrastructure which is provisioned. The concept varies when you do it in cloud, in the sense that you don't need to have everything in place. You can configure things that as and when your traffic increases, how your auto scaling policies gets triggered, how servers gets created in a dynamic mode, how containers gets spun in a dynamic mode. Right. So the concept remains the same. It is how you implement it, whether it is on-prem or whether it is on cloud. Cloud offers you the flexibility of doing lot of things dynamically, but unfortunately, on-prem you don't have that flexibility. You have to do a lot of forward planning. You have to provision a lot of servers beforehand, configure that beforehand, because anything as a code is not possible on on-prem, right? Infrastructure as a code, platform as a code, software as a code, configuration as a code, all these concept works for cloud, not for on-prem, right?
Correct, yeah.
So yes, whether it is traditional on-prem infrastructure, whether it is modern cloud infrastructure or container infrastructure using Kubernetes, the concept remains the same. The associated complexities are related to its implementation. All right.
All right.
Excellent. So,
Aniket, so what we see is like SRE is mostly applicable to cloud-based apps or like
no, it
on-premise
is
apps
it
also.
is applicable to both cloud as well as on-prem. I mean, we are talking more from a cloud perspective because that is where the industry is heading towards, right? Uh, Whatever on-prem based applications, most of the organizations are within next few years. You can see that uh, it is gone. Most of the organizations are transforming towards cloud, right?
And also, can you little explain on the flow? Because I saw the CI/CD flow, but
Mm,
in our day-to-day life, like as a developer, we interact with operations or different teams and testing. So you mentioned different kinds of tools we have to implement as part of SRE automation process.
yeah.
So as a SRE engineer, like what will be my role? Like should I work with testing teams or like should I suggest them like okay you should go with this tool or like what will be
So
my
as a site reliability engineer, and yes, you are right. Okay, I'll tell you one thing. Don't get confused, because whatever we are talking here is a very standard approach. You cannot just like that go ahead and start translating this theoretical approach in your organization, because whenever you need to bring a transformation in any organization, you need to take baby steps because it is a cultural change. So I don't think whether you can straight away go ahead and say that no, I am a SRE, I'm going to do this, blah blah blah. It will create a kind of problem for you. So as a SRE, right, you need to start that level of
Mosquito put me.
education to your development community, to your testing community, to your ops community. You need to start them educating on the best practices related to these aspects which they generally miss. For example, you can start talking to the product owner or the scrum master, right, in the sprint one, and when they have no clue about non-functional behaviors of performance, capacity, security, infrastructure, right, you can start educating them. Oh, can we start thinking about this? Can we think about this, that as well, and blah. You set the scene. Okay, so it has to be done in a baby step. And in the industry, SRE is a spoiled word as of now, and sometimes I really feel bad about it. I'll tell you why. I have seen that most of the companies, what they do, some of the company have just renamed their production support or ops team as SRE. Okay, whoever were the production support staff or colleague, now their job title is changed to SRE, which is good. Good in the sense that at least they have started adopting it, but that's not SRE. That's not SRE. Translating your production support or support team or the run team and calling them as SREs doesn't justify things. But yes, it is a start, good start. Some of the companies I have seen that earlier they used to have a performance testing center of excellence or performance testing capability. Those performance testers are now SRE. SRE doesn't mean that you just do performance testing, right? So that is how it is there. But as it is in the very earliest stages,
It.
evolving a stage, right? We expect that in next few years, there will be a level of maturity. Okay. But when you have to implement that in your organization, what I would request you is that the learning that you gain from this course, right? You take baby steps and start propagating that into your development test ops community, right? And slowly and steadily build on top of that. That's how it will take you to success. Okay. Any questions further? Right. So, I mean, as a part of anti-fragility strategy, as we move on in next chapter, we will talk about chaos engineering, which is an evolving or which is a very super duper new concept
నీ
from a
ఫేవరెట్
site
దా
reliability engineering
ఓకే
perspective. So,
మీ ఫేవరెట్ కదా
chaos engineering, I'm not going to talk much about here because, anyways, we will have it later. There are tools like Chaos
ఏదైనా
Monkey is one of the tool, right, which is used for
బ్లూ
chaos engineering.
బ్లాక్ కమ్
Chaos
బ్లూ
engineering
కరెక్ట్
is directly
కమ్
related to anti. So, when you build in anti-fragile infrastructure or anti-fragile application, then you test it. You test the anti-fragility of your infrastructure application. And sorry, one thing I missed to tell you, we are talking about the anti-fragile nature of the network as well, right? If network is not anti-fragile, then also it is a problem, right? So uh, even if we have anti-fragile network, infrastructure, hardware, software, right? Focus is always from a wisdom of production perspective. Okay. Wisdom of production is a very important concept, which uh, you will have only when you have experienced the pain of production. If you have not experienced that pain of production, then you will not be in a position to achieve that wisdom of production. It is not just service automation, it is end to end automation. Right. Here in this particular slide, you can see how the automation has been implemented. So this is a kind of pyramid, right? At the very bottom, if you see, it is mentioned as none. So we are talking about an example of database failover. So let's say that if we have to fail a database, right? In the absence of automation, how we can do that? We can manually fail that, right, database, right? If I'm a database administrator, I will go ahead and manually fail it. That's what I will do. Let us go one step ahead. What we can have an externally maintained system specific automation wherein uh, I have got a failover script on my laptop. I will trigger that failover script and that will fail the database. Let us go one step ahead again. We have externally maintained generic automation. And what it is, I mean, instead of having that local script on my laptop, I will place that script on a SharePoint portal or on some shared repository, and that can be
ఎందుకు
used
అట్లా
by
అన్నా
my entire team, right?
వెయిట్
So that enhances
ఇది
the
పెట్టుకో
flavor
ఫస్ట్
of automation. Again, one step ahead, we have internally maintained system
అట్లా
specific
ఎందుకు
automation.
అట్లా చేసిన
So where the database ships with its own failover script, right? I don't need to write anything. So the failover script comes inbuilt with the database. Okay. And
వాష్ చేసుకుందా
I don't need any
దా
internal or
వాష్
external automation. It is a part of the package. The final bit of it, which is the most important thing, is the database, once it notices there is a problem, it automatically fails over and then automatically restarts without any human intervention. So you can see this should be the hierarchy of automation types, uh, which is not that easy to achieve in any organization. It's just a simple example, but we need to visualize it at a very broad level, at a very um, departmental level, at a problem level, right? Whatever is the problem, and for that problem, what
అట్లా అన్నావు
automation hierarchy we can achieve. So here we are talking about secure automation, and mainly secure automation. When we talk about, right, it is we are talking about the security aspects of the code. If you remember, I told you that as a part of the build process in the CI/CD pipeline, uh, as a site reliability engineer, we also need to ensure whether our code is written in a secured way or not. And for that, we do static application security testing, SAST. Okay. So there are certain industry standard tools, and some of you who are close to security, you may have worked on it. SonarQube is one of the tool.
అమ్మా
So SonarQube, you need to configure it as a part of your build pipeline. It runs, it scans the code, and it will tell you that on that piece of code what the
అక్కడ
vulnerabilities are, what the code
జడ్జి దగ్గరికి
smells are,
వెళ్ళాలి
what are the best practices that are violated, not followed, right? So as a part of your build activities, you are securing your application code. And that way, the advantage is that um, when you follow a sprint based approach, right, every sprint when you do the SAST scanning, uh, and identify the flaws, it gives an opportunity to you to fix it very early. And when you fix it very early, then after 1 year when you are going live, right, then at that time the probability of finding any security vulnerability at a source code level, it reduces. Similarly, you are not only limiting to the static testing for your code. Once your code is run, right, once your code is compiled and it is running, right, then at that point of time you can do dynamic application security testing, which is called as DAST, right? And DAST is the main objective of DAST is to identify security vulnerabilities when your code is in a run state. Okay. And how exactly that is done? Basically, there are industry standard tools. Again, you may have heard of, you have got Vera code, you have got a tool from OWASP called as ZAP, Z Attack Proxy. That is one of the very good tools. I have used it personally. You can configure ZAP to your application, and once that runs in your runs for your application, uh, against the OWASP top 10 or 15 standards, it will try to find out the security vulnerabilities in your code, whether something related to fuzzing or something related to, um, let us say, SQL injection, or related to man in the middle attack. You can test for all these things using DAST. So we need to ensure that, I mean, from environment perspective, all our environments are secured, right? Whether we are talking about the lower environment or root to live environment where staging comes into picture, right? We need to ensure that everything is secured. And now the concept is about immutability, right? Immutability of infrastructure is something, let us say, uh, that earlier days, if I had 100 servers in my data center, and if all the 100 servers, right, which was a pain. I mean, uh, the infrastructure was not immutable at all, right? I have to somehow work on whatever infrastructure is available. But now, let us say that if I don't want to do that, I mean, if I have a container which is running uh, on a Kubernetes cluster, then if I need to make some changes into the code onto the container, right, I have two options. Either I go ahead and manually uh, or in an automated way make the change in that container, or other option is that I don't care, just kill that container and just replace it with uh, another container, right? Because containers creation, container life cycle is very easy to manage compared to a normal physical or a virtual server, right? So the overall concept is that, is our environment immutable, whether it has got that immutability facility built in or not. And so by default, when we talk about cloud infrastructure, when we talk about the containerized infrastructure, immutability comes into these by default, right? Key thing here is we should never forget that we blindly rely on the security of the infrastructure. So we need to have, as a SRE, we need to advocate the infrastructure security scanning as well on a regular basis, right? Because nowadays the vulnerability is specific to container security, or vulnerabilities is specific to Kubernetes security or cloud security, it is increasing. So we need to have a mechanism in place that on a regular basis we scan all these components to identify the security vulnerabilities associated with the
Idli.
infrastructure. There are again
Idli.
tools
After
associated with that, right? It depends
Kichdi,
on
night dosa.
what is available in your company. But I mean, the most standard tool for cloud scanning is, I have heard, which I personally used, was there's a tool called as Prisma Cloud. So Prisma Cloud is basically for any of your cloud infrastructure scanning or container scanning that sits on your cloud infrastructure. You can
Nani.
uh, read about that. Similarly, I mean, all the environments we need to really secure, whether it is a staging, pre-production, production. So, I mean, how many pages are left here? Let me see. This is a relatively bigger chapter. I think it's been a while, right? I'm sure all of you would be looking for a break. So let us take 5 minutes break and then we can continue. Yeah,
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 please.
thank you.
yeah, yeah.
Yeah, thank you.
Edu bitnyo, ఇది పెట్టుకోండి
Hello, participants. Are you back? Kindly let me know as soon as you're back. Okay.
Hi, Aniket, I'm back.
Hey, Richa. Yeah. Let's just give a minute more. All right. So I think this is a bit lengthy module. So that is why it is taking a bit more time. But let's not worry too much. We will be completing that in next few minutes. There are a few very theoretical example related things that you can read on your own. I am not going to spend much time on that. Thank you. Thanks a lot, Prem. So here, the main focus is talking about, can we be in a position wherein we really introduce self-healing capability into our IT systems, and that is an evolving concept which has started working, and I can see that. So self-healing, as I told you the example of microservices architecture, right? Uh, it is self-healing. So microservices, if you're writing your code in microservices, right, and if the code has some problems or if the code crashes, right, then you don't need to again log into the microservice container and again restart the container. It will automate, the container will automatically restart. You don't need to worry about that. Similarly, if we talk about cloud based infrastructure, right, if there are any issues, then it has got self healing capability. Cloud has got self healing capability. If any cloud component EC2 instance fails, then AWS provides you with the capability that yes, it will restart on its own. Or if there are any issues, right, it will try to fix it implicitly on its own. They have got some AI capability or machine learning capability inbuilt, most of the cloud service providers. From a SRE perspective, the way we do it is, and especially I'll take an example related to monitoring. um, I was talking yesterday that Dynatrace has got AI capability. It is now more AI ops centric. What exactly does it mean? It means that uh, let's say that uh, you have got a problem. Dynatrace detects that uh, there is a problem in uh, uh, one of the database, RDS, relational database services. And the problem is that the database connection pool is getting exhausted after a particular uh, traffic is injected into the database, right? So Dynatrix identifies that. So the traditional way of doing that is, okay, fine, the database connection pool is getting exhausted, the database will shut down, then users will start experiencing problem, they will raise a production incident, it will be triaged, then at some point of time it will be fixed by the DBAs. So end to end, it is going to take n number of elapsed days, right? But now with this self-healing capability that the monitoring tool provides us, Dynatrace has got this AI, inbuilt AI engine, which detects that yes, some problem is going to happen. It constantly keeps on monitoring the database connection pool. And as a part of that monitoring, when it senses that yes, in few minutes it is the connection pool is going to get exhausted and it will have a problem. What it will do is you need to configure, again, configuration plays a very important role. So you need to configure Dynatrace in such a way that using the Dynatrace service account, service user account, you automatically establish a connection to the, let us say, Oracle database, right? And you configure that service user or service account, give that level of privilege to the service account that it automatically goes ahead and make changes into the um, connection pool settings of the database. So that way, see how intelligent the system is. Dynatrace detects that there is a potential problem likely to happen. When it senses that, then you have configured that intelligence into the system that as soon as Dynatrace senses a particular condition, depending on the nature of the condition, it will go ahead and make a connectivity to the Oracle database using the service account, and it will dynamically change the value of the connection pool. Let us say that it is set to 10, it will increase it from 10 to 20, right? So that way, that self-healing capability is inbuilt. You don't need a ops team over here. You don't need incident management over here, right? This is a simple example that I told you. So in the same way, I think in next few years we can see that the incident management team or the production support team, whatever now are inundated with tickets, that volume is going to reduce because of that self-healing capability. Okay, but this example that I told you, right, it is more in front of I mean in the context of configure. So wherever certain configuration related things can be changed to improve the reliability of the system, this is a typical example of that. But I don't know if there are some issues at a code level, right? Obviously, until and unless a code a developer doesn't manually rectify it, right, it's not going to happen. So it is relatively easy. The self-healing capability is relatively easy when we have to talk at a configuration level, at an infrastructure level, but at a code level, in my opinion, I think is still long way to go. That self-healing capability, we'll have to see how exactly it matures. Now, related to various steps, I mean, right from management, planning, creation, verification, packaging of the code, security of the code, release management of the code, configuration of the code, monitoring of the code, and defense of the code and defense of the infrastructure. There are multiple tools, automation tools that we can see in the subsequent slides. As I said, I'm not going to exhaustively read all these things. These are a bit theoretical. You can read on your own. So from a management perspective, we are talking about audit management. We are talking about authentication and authorization and certain tools specific to that. DevOps score, value stream management, which I briefed about yesterday what value stream management is. Planning perspective, how do we track issue, Kanban, time, agile portfolio? All these are very, very theoretical concepts. You can read about it. Again, service desk, requirement management, quality management. There are tools associated with all these things, and most of known to you, not new, but it is just a structured way for the various steps. How we do source code management, we talked, we either use GitHub or GitLab or SVN if we are using it on-prem. Code review, available in all the monitoring tools. Dynatrace, it is available because Dynatrace has got that AI and machine learning capability. But other tools may have as well, which I don't know. But yes, I can confidently tell you that it is in Dynatrace. Vulnerability management, we talked about it. DLP is data loss prevention. Most of you are working in banks. You know what data loss prevention is, right? Securing the storage, right, is another important thing. Container network security is another. So when we talk about containers, right, two containers are there. So the containers always talk to each other, and that mechanism is, they call it as service mesh, right? So one container talks to another container in a cluster or in different Kubernetes clusters using service mesh. So ensuring that the container network security is not compromised. We need to take utmost care of it. And how we take care is by setting appropriate policies, network policies at a container level regarding what can access, who can access the container resources. This is a very amazing video. Have a watch of this. And what do we need in place about anti-fragility and learning from failure? So this module, we have anyways clarified our fundamental understanding about anti-fragility, but let us learn a bit more about anti-fragility uh, specific to the training content or the training material. So this is one of the major mind shift that you can see, right? What Tony is saying is that there is no such thing called as failure, only results. It is time to stop beating yourself up and start realizing that everything you do is a success or a learning experience. Isn't that true? It is a
Yes,
very
absolutely.
simple statement, but very powerful as well. And if we start implementing this thought process in our teams, in our organization, then over a period of time, it is going to bring a drastic change in the culture, right? So nothing called as failure. Very true. I mean, whatever we do, right? We have been taught that, yeah, the outcome can be either a pass or a fail, right? That's how we have been born and brought up and taught, which is true. But we are not talking about anything which is uh, a life and blood over here. We are talking about IT systems, right? So when we talk about IT systems, obviously, right, it is human born, human developed. So something can work, something cannot work, but something that doesn't work, right? Uh, are we in a position to learn why it is not working, and are we in a position to explore why it is not working, and then as a next step?
This is
So
laptop
that
one.
that is what it
Who
is,
put it?
right?
You
That's
took
what
it
he's
out?
trying to say. We need to change the reputation of failure. Failure should not be perceived as a bad thing in any of the organization. Failure should be perceived in a positive way, as a learning opportunity, as a better experience in the organization. Then only the mindset shift will happen. Otherwise, it will be difficult. Right. Why it is important? Because these are the five things. We need to be better at breaking things. Whenever you talk about breaking things in any organization, right? People see you, and especially the project managers or the program managers or the product owners who have the responsibility of budget and all, right? They'll see, oh my God, he's talking about breaking things. It means that if he breaks things, then fixing is again a problem, going to take a lot of cost, incur a lot of cost. So this culture of breaking things is not prevalent in many organizations, right? Simple example is that, okay, I want to test a scenario wherein I want to identify that if I kill one server abruptly, whether my other server is willing to cope up with the load, right? You want to test that and you want to be prepared for that. But if you talk to your boss, your leader, your project or program manager, who can be either a very amazing person, very learned person, support you to prepare for the worst, or if he is a traditional person, right? He may challenge you. Why? Server will not go down. Why do you think that the server will go down? Server will never go down. Are we spending so much for having the server down? I mean, illogical things, but yes. Um, there are certain set of people or leaders with whom you can't win, maybe because of the authoritative nature or because of the prevailing culture in the organization, but that is how it is in reality. So until and unless we do not exploit the system, the IT system design, architecture, infrastructure, we don't think what if we don't uh, talk about why, right? It is really a difficult situation. So only when things break, right, we know how to fix them so that we can prevent things from breaking. And ultimately, everything is improving us, reducing our downtime and increasing our business footprint, right? So risk versus benefit is something which is the key parameter over here, or are we talking about just incorporating new features after features without thinking about anti-fragility? So these are the parameters that needs to be thought of. Firefighting. I mean, we often end up in firefighting most of the times, especially after a go live or especially in the warranty phase, right? So that is not new, but I mean, uh,
Yes,
we need to be prepared for firefighting,
regarding
right?
property.
So from this slide, the importance or the analogy is that we need to be better in tech in dealing with issues, which is basically fires, or in particular certain type of issues, maybe some specialist fires, right? We should know what to do when things go wrong, and this requires training, preparation, and training. Um, if we are not done with that, then it becomes very difficult. A very simple example that I'll tell you is uh, we talked about the DR capability, right? We talked about how we architect infrastructure, do deployment in a cloud, in a region, in various availability zones, right? Most of the companies, they uh, do not have a DR policy when they have cloud, because they think that, okay, I am deploying my application in a single region. That region has got multiple availability zone. So they think that, okay, multiple availability zone is implicitly giving them the DR capability. If one availability zone goes down, other is available. If other goes down, other is available. So on an average, in one region, you have got 3 to 4 availability zones. And I'm not saying that it's a wrong strategy. It is good, but there is a difference. There is a difference between high available systems, highly resilient systems, and disaster recovery. Disaster recovery has got two key flavors. One is called as RPO, which is recovery point objective, and another is called as RTO, which is recovery time objective. So recovery point objective is basically, let us say that if you get a failure now, right? Does your system have the capability for recovering the data for, let us say, next for not more than 5 minutes, 10 minutes, 15 minutes? Every organization it varies, right? If you don't have that capability, if you have not tested for that worst case situation, if you do not have a run book defined that if this happens, then what are the steps that needs to be done to bring back to normal state, then you are not prepared for doing that firefighting if it happens in the worst case. Recovery time objective, right? Let's say that some organization has RTO for 2 hours, 3 hours, 4 hours. It varies from organization to organization. It varies from application to application, right? So it means that if the worst happens, right, then do you have that capability to bring back to the normal working state in 2 hours, 3 hours, 4 hours, right? And how do you ensure that? You need to be prepared for that. I think those of you who are working in this particular area in your companies, you would have done a lot of dress rehearsals as a part of DR, RTO, and RPO. You will have well documented processes. You will have well championed teams who have done that, who have rehearsed that, so that once it is needed to done in the actual event, they are well prepared for doing that. Yeah. So the key thing here is that yes, at a cloud level, I told you what is the thought process, but uh, I always encourage that let us not only rely on a single reason, right? We need to have a multi-reason DR capability because disaster has to be always thought of in the worst possible way, right? Yes, the risk is low. All the availability zones cannot go down at the same time. The risk is low. But what if the entire region goes down, all the availability? And you might not know, the funny part of the entire thing is that none of the cloud service providers give you in writing that, let us say, if their region goes down and when it comes back again, they will not assure you that your application will be in the same state. So it may be that, let us say, you have configured your application is running on 10 servers and disaster strikes, their region goes down, and let's say in next half an hour, 1 hour, the region comes back. They will not guarantee you that you will have the same 10 servers up and running. It might be that out of 10, you just have 6, 7, 5 running now, remaining 4 might have gone. So in that case, if it happens, then are you prepared for it? And that is where testing for these different scenarios, different combinations plays a very important role. And when I say testing, I mean uh, I'll tell you my experience, which I have done very recently for one of the greenfield projects programs for an insurance company on AWS. Uh, Brand new technology, Kubernetes cluster, Docker containers, uh, 4 availability zones they had. So I designed a test strategy, and it was a kind of a chaos engineering, chaos testing, right? Uh, uh, what if one of my availability zone goes down and all the Kubernetes pods goes down? So first thing is you have a Kubernetes pod. On that pod, you have a microservice. Sorry, you have a container, and on that container, you have microservice. This is the architecture, right? Kubernetes pod, on top of the pod, container, on top of the container, your microservice, right? So let us say that you have got 2 pods running in a availability zone. The first level of chaos testing What will happen if one pod is terminated abruptly? That helps you to understand the behavior of the application. What if I terminate both the pods on availability zone? I cannot bring down availability zone because eventually you do not control that. It is controlled by cloud, right? But what you can do, you can simulate that. You can terminate both the Kubernetes pods. So once you terminate both the Kubernetes pods, then the remaining three availability zones, how they deal with your traffic. Then you terminate two availability zone pods. What is the impact? You try to understand and analyze the impact under various situations, various flavors. And that helps us to architect the application that in the worst, if out of four availability zones, three goes down, then I have designed and architected my fourth availability zone to cope up with the worst case traffic, the worst volume. So if we have designed that, I mean, we are prepared for the worst in one reason. Yeah. So having multiple failover tests at a container level, having multiple failover tests at a Kubernetes pod level, having multiple failover tests at an availability zone level. So when you, I mean, it can be more than 100, 200 tests. You'll have to design multiple permutation and combination of tests, right? Then the RTO for the RTO requirement recovery time objective was 4 hours for that company and that project. What will happen? Do you have that capability that in case if the entire region goes down, if all the four clusters goes down, do we have that capability to build all the infrastructure on AWS cloud right from scratch, get the code deployed, right, and then bring back the application as it was before disaster in a 4 hour window? Do we have that capability? Until and unless you don't test it, you don't rehearse it, you do not have a proper run book with all the steps. Will you be able to do that when it happens? No, you will not. So that is where the importance of being prepared for that firefighting is. Or alternatively, this is very funny, right? Always pray God that, oh my God, hope this works, or let me do some changes here and there. It will make things work. Or yes, let us Google the error message, which all of us love to do. Failure happens. There is no way around it to stop pointing fingers, right? So the emphasis is it will happen. We don't need to finger point anyone, right? Embracing failure will help improve the MTTD, mean time to discover, and mean time to repair metrics. Proactively addressing failure leads to more robust system. So which are the metrics that will improve? Mean time to detect, obviously. Mean time to repair or recover, obviously. MTRS, mean time to recover a service. SLO and recovery point objective. That is what we talked about, the example that I gave you. Right? So all these metrics are drastically going to be impacted or improved when we have anti-fragility built in. Right. Recovery point objective. One tricky thing is one, you need to know that when we talk about recovery point objective, uh, we always talk about data. So recovery point objective requirement will always be related to data. Okay. Simple example, I'll tell you that I have a database, right? Uh, and I'm taking the backup of that database every 10 minutes. Hmm? So it means that from now until next 10 minutes, whatever will happen in my database, whatever commits right will happen in my database, that is not going to be backed up until that 10-minute window is completed, right? So we'll have to see what is the flexibility that the database backup mechanism offers. Some database mechanism offers real-time replication, right? So immediately now something is committed into your database, the same thing is committed into your replica as well. But some databases, like if you see traditional databases like Oracle or SQL Server, you have to configure, right? I think it provides 5 minutes or 10 minutes. What exactly it means is that, let's say that if your recovery point objective is 10 minutes, right? So in that case, uh, uh, you will have to configure your database backup and recovery accordingly. If your database recovery is positioned to achieve that 10 minutes, you'll have to increase that RPO objective. So what I'm trying to say here is you need to understand the recovery strategy that your database provider can offer you, and based on that recovery strategy only, you need to be very realistic about your recovery point objective requirements. Yeah. So if you are having a database which offers you a more frequent backups, let us say every 5 minutes it is allowing you to backup, or every 2 minutes it's allowing you to backup, or it is providing you the backup flexibility in real time replication, then y- you can have RPO for a very less time. But if you are constrained, if your database uh, uh, partner or database vendor tells you that I can provide you with the backup only every 10 minutes, then in that case, you cannot have a RPO of 10 minutes. Your RPO should be 11 minutes, so that you know that every 10 minutes the data is backed up. You are either a learning organization or losing to someone who is dot dot dot, right? We all know what dot dot is. So the emphasis here is creating a culture of learning from failure, which is very important. Now, how do we do that? Have you, any of you know, or have you heard about the three ways, which is one of the fundamental uh, principles of DevOps? Any of you have heard about three ways? No? No? Right. From dev to ops. If ops experiences a problem, immediately feed it back to dev, right? Dev fixes that, goes back to ops. Same thing continues. So you are amplifying the feedback loop so that the overall elapsed time is reduced. That is the second way. And the third way is called as continuous learning and experimentation. You are empowering your team so that they continuously experiment, continuously fail, and learn from the failures so that it strengthens both the dev and the ops capability. So that is what the third way is: continuous experimentation and learning. So if any organization is practicing the third way, it means they are empowering their employees to inculcate this behavior of learning from failure. Okay. So any organization, if they want to embrace DevOps and SRE, they need to emphasize much on the third way. Now, this is a very important model. I think some of you may have read it. This is called as Westrum model. According to Westrum, uh, there are three different flavors of organization, right? Pathological, bureaucratic, and generative. Pathological is basically a power centered organization wherein, everything is bureaucratic. Everything is bureaucratic. And if there are any failures, then most of the times or always it is covered up, right? Because people are afraid that if they're going to announce the failures to their bosses or managers, then they will be fired. They'll be fired or there will be severe penalty. So that kind of organization, power oriented organization, is called as pathological. After that, bureaucratic, as things started changing, right, from pathological to bureaucratic. So bureaucratic is basically a rule oriented or very very highly process oriented organization, right? uh, there as well, if you see, right, if you do commit any failures or anyone commits any failures, to some extent, I mean, it is okay compared to pathological, but still it is not that great, right? There is a lot of blame game, there is a lot of finger pointing, uh, which happens in case if failure takes place. But where we want to head towards, or where most of the organization would need to head towards, is the generative model, which is performance oriented, where if any failure happens, then there should not be any finger pointing. Failures should be treated as normal. But yes, there should be a culture to do a blameless post-mortem. We call it as a blameless post-mortem, right? Do an analysis of why the failure happened, what caused this, what we can do to ensure that we prevent it from any future recurrence, right? That analysis definitely should be done. I mean, in a positive way, in a learning way. That is something which is a quality of a generative organizations. Okay. So I'm sure you will definitely get one question from this in the exam. So just remember this Westrum model of organizational culture. Introducing fire drill, I think we talked about. I mean, fire drill mainly when we talk about it is related to DR or the business continuity planning, and we need to be prepared for it. It is a audit requirement as well. So when we talk about fire drill, right, uh, we it can have many flavors, right? We are not only talking about the loss of a particular data center or a facility or a particular region or a particular availability zone, right? That's one flavor. It can be loss of a particular technology as well, right? It can be loss of people side of things, right? Lack of I mean, loss of resources. A key person who is working on something, who has a lot of knowledge, and we are losing him. Either he has resigned or left the organization, or he's absconding, or xyz, any other reason, right? Or loss of other third party vendors on which we have a major reliance. So there can be multiple flavors of it for which we need to be prepared of. Now, chaos engineering, and this is where we are heading to. This is a concept that came from Netflix, similar to SRE. SRE came from Google, right? So chaos engineering came from Netflix. And why Netflix started that is when once they started this video streaming, online video streaming business, right? It was the first kind of company to start that. And in the initial phases, it experienced a lot of problems, lot of problems. Okay. Users sometimes complaining that there are buffering issues. Sometimes because of high load, right, there were issues related to performance. their server getting crashed because of high load, and users were not happy with the end user experience. So it has a lot of teething problems initial few years. That is where few of the great minds in Netflix, they started thinking that yes, let us be prepared for the worst, right? uh, they had a lot of their engineers who used to have multiple overnights, working 24 bar 7, which created a very bad culture in the company, right? And that is when they came up with this concept of chaos engineering. It took a bit of 1 to 2 years for them to come up with an approach. They designed some inbuilt tools as well, but um, slowly and steadily they came to that situation wherein, uh, you may not know, this is the only company in the globe who does testing in their production environment. Any testing and every testing in production. They have reached to that level of confidence and maturity. So they have developed this suite of tool which is called as Simian Army, right? To test the various chaos or the chaotic behavior of their infrastructure. See their thought process,
ట్వెల్వ్ థర్టీకి
how
ఎందుకు
they are making themselves
లాలబోపి
prepared
అలాడికి
for the worst,
నీకు
right?
చెప్పిస్తా
So it
బాగుంటుంది.
is
నీకు చెప్పిస్తా వాడు చేసినట్టే.
Simian Army, and to be honest, I tried to use these tools, but my organization didn't permit me. I had a lot of challenges in using these tools, and that is where I have to think out of the box. That without the tools, how can I do chaotic testing, chaos testing? And the previous example that I told you, right? It was doing the testing, chaotic situation
నువ్వు
scenarios, and
చూస్తున్నావా?
doing it in a manual way
నేను
without
చేద్దాం
the
అనుకుంటున్నా ఎవరో
usage
అని.
of any tool. But in the case of Netflix, I mean, how they did it. They have this suite of tool which is called as Simian Army, and Chaos Monkey is one of the tools in the suite, and it is really amazing, really amazing. What you can do is, if you have got, let us say, 100 instances running in production, 100 servers running in production, right? Using that tool can randomly kill anything. I mean, depend. You need to configure how many you want to terminate or kill. So Netflix wanted to experiment that. Let us say if my production infrastructure is running on 100 servers, I should be prepared that in the worst case, if 50% of the servers goes down, then still the users um, um, usability should not be compromised, right? So to deal with those kind of situation, they came up with this tool, right? And that this tool is constantly doing testing in production. It's not like that they have a test phase, right? I mean, on a regular basis, on a daily basis, they will randomly terminate uh, clusters, and their main objective is to reach to that stable state wherein, I mean, if the worst happens, my engineers should not worry. They should not have a sleepless nights. Same thing, similar to Chaos Monkey. Another tool that they have is uh, Chaos Gorilla, right? The names are fascinating, uh, and that uh, simulates. I mean, if you want to simulate I need to be prepared for infusing latency into, right? So because I hope you have experienced it or not. I mean, if there are latency, right, then obviously it impacts your buffering. And if you buffer, then you have two options. Either you will have the circle whirling around and you will get annoyed, because they are online movie company, online video company. They simulated that. And the way in which they simulate it is that, let us say that you introduce a delay, network delay, in such a way that you are watching a movie on ultra HD. If you are introducing this much of delay, right, it means that from your usability perspective, it should not be impacted.
Papia,
What it will do
are you
is
puppy?
it will
Why?
degrade from ultra HD to HD if it senses that
It is
yes,
your
this
glass.
delay is
Today's
there.
one. Ippatide.
If beyond that delay from HD, it will shift to
Hold with
SD, a
mouth.
standard display. So it tries to ensure that your usability
Puppy.
perspective
Hold
is
with
not
mouth.
improved. You don't get into that whirling screen, right? So that's the main thing that this tool does.
అమ్మ చూస్తున్నాయి.
So
Tell her.
next steps for chaos engineering. I mean, the key thing for implementing chaos engineering is a very thorough end-to-end understanding about your application landscape, about your hardware, software stack. Uh, if physical diagram for an infrastructure, just imagine that right from the firewall, right, until your database layer, you have a complete
I love
visualization that
you.
okay, firewall, then web server, then again a firewall, then a lot of app servers, then again a firewall, then DB servers, and then again what's the connectivity to the third party, what's the connectivity to any COTS product. You need to have an end-to-end visualization, and then at each layer you can think of how exactly you need to architect your system to deal with the chaotic situation. And once you are confident that your architecting and design is really meeting that, then comes the question of how are you designing scenarios to test it, right? That is what it is talking about. And once you decide scenarios, you start injecting failures as per your test case, as per your test scenario, and test it. The thing is, the most important thing is that what are the learnings when we do chaos engineering, right, and the associated testing. Monitoring is very key. We need to ensure that we have the proper monitoring utilities, because if we are not monitoring it in an effective way, we will not have the data to allow us to really analyze and interpret in a technical and granular way, right? So monitoring is really key over here. uh, Analyze the statistics of monitoring, and then see what needs to be done to ensure that the learning from chaos testing is something which makes the system more robust. Right. This is a blast radius. So blast radius, I mean, if you see any explosion, right, at the place where the explosion takes place, the intensity of the blast is very high, so it creates a complete destruction. But as you move away from the place where the blast takes place, I mean, as the blast radius increases, the level of destruction decreases, right? So that is what it is. Chaos engineering helps us to minimize the blast radius. So if we have not done chaos engineering, if we have not architected, designed, and tested our system for chaos, then it will create a lot of destruction
Close your tongue.
in production. The blast radius will be very high, right? But if we have already designed, architected, and tested for the various chaos scenarios, then in that case,
Vichikana, I love you.
we can minimize the blast radius,
నిన్ను
or we
తింటా.
can completely nullify it. Or let's say that if we are not nullifying
నేను
it
మురుకులంతా
completely, at
అయిపోగొట్టినా.
least the blast
వాడు
radius
తినట్టు
will be
నాకు తెలియదు.
reduced.
వాడు నువ్వే పెట్టు.
Yeah, that's what it says. How do we do that? Yes, we talked about creating immutable infrastructure as a code, which most of the cloud service provider has. We need to have a lot of automated testing, both functional as well as non-functional testing for various scenarios. We need to have an effective monitoring system so that the monitoring specific data can be analyzed in an observable way. We need to have a very smart alerting mechanism in place. We need to have the self-healing capability at an infrastructure level or at a code level or at a configuration level, and repeated testing. That's the most important thing.
My cute,
Test,
cute, cute.
test, 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 because uh,
My
every
cute
day
issue.
there can be certain new scenarios
Puppy, my
that can be
cute
thought
puppy.
of, right? So until and unless you don't test it,
I
you'll
love
not
you,
be able to
puppy.
understand the chaos that a particular negative scenario can create. Yes, automation can help. Here, the main focus is on auto scaling that we have talked about many a times. But again, if we are not doing chaos testing, we will not be able to configure auto scaling in the best possible way.
Daddy puppy, Nana. Issue puppy, daddy puppy.
Let us attempt the quiz. Modules are usually covered up by an organization. Then that organization is what? Mainly talking about the organizational impact of site reliability engineering. Okay, so what are the key drivers that organization wants to embrace SRE? So obviously, one of the key drivers is uh, no one wants a service outage because nowadays we know that if there is an outage for even a minute or couple of minutes, then brand reputation is at stake. It is compromised. So certain sites like Down Detector, right, you can see it gives you a history of all the outages for all the top sites, top service providers across the globe. Right. So there is an increased focus on service resilience for most of the organizations. Now, everything if we see, right, any downtime is related to a loss of revenue. So this is a very important statistics which says that average cost of service downtime is $5,600 per minute. This is the average cost, and uh, it is depending on the nature of the business as well. It ranges from 140K to 300K per hour on an average if the application is really complicated and complex, and 540,000 at the higher end, which is something, to be honest, right, I didn't had much of interest on these aspects, but now some of you who are at leadership level, how many of you are aware that in case if your application is down for 10 minutes, how much business revenue loss it gives to you? Any of you have
Will
even
not
thought?
know will not know about the dollars level. Always the business will not say about the dollars, most probably.
Hmm.
Mostly if any reputational or operational loss they used to say, but mostly they will not reveal the dollars.
We will know the production impact, so I mean number of users who were down and for the time duration. So
Right.
productivity loss is what we will know.
Okay, good. It is not that easy, and I'll tell you, I mean, my experience, because when you have a legacy application, right, running for a bank or for an organization over a period of time, then obviously finding that details in terms of revenue loss uh, per hour or per day or per minute is a bit difficult, because you need to have a lot of analysis done, a lot of interviews done with the a run team, with the production support team, with the business team, and technical people generally lose appetite when they have to do all these things, right? But I faced challenge, severe challenge in my in the same program that I told you, that insurance client. And the challenge was that if you do not implement disaster recovery at a region level, then
Perta perta wait.
for the what revenue in
Nije.
a way that really helps provide data points. And because it was a brand new product from the company for selling motor insurance, car insurance, right? Mm, there was no data as such which I can use. So application went live last year in
Devi.
April, and I started monitoring the live metrics from April until November. New nature of business. You can month by month data I had, and every month, I mean, as a IT, I cannot see what was the cost of the insurance, uh, but that data was something which was there into the
Why are you coming?
done every day, every month. And in due course of time, I mean, for these out of 8 months, I did the analysis for 6 months, came up with a trend on how the user profile was growing, how the business footprint was growing, how the revenue was growing, and uh, that gave me an average view uh, and a peak view. That in the average case, uh, in the peak hour, this much, these many pounds are the revenue. In the average hour, this much is the pound, which is a revenue. And that tells you to visualize a situation that if there is a downtime during the peak hour, how much revenue you will lose. Because everything was data driven. I had data to prove that. And no one can challenge when you have data to prove that. So with that statistical analysis, live analysis, the only advantage I had was that it was a brand new business, brand new system. So everything was from scratch. And then what I did was I did a kind of extrapolation, a linear extrapolation, that for 6 months this is the business trend. If we visualize the situation for next 5 years, we are expecting this much of business growth in the monetary value. And let us say that the fifth year, if let us say this much million pounds of revenue we are talking about, and if we have data center loss or reason loss for Amazon cloud, right, how much revenue we will lose. So with that statistical analysis proven by data, uh, uh, I was able to convince the CTO, and he finally agreed that yes, it makes sense. So that's the way, that's one of the approaches in which you can, although we are into IT, we are not much worried about the cost implications, but yes, we should not blindly trust as well that someone is saying that this is the cost implication, this is the revenue loss. Okay, how does it work out? So this is one of the way in which you can do. In fact, I did that for one of my engagements. One of the ways to translate the downtime into the average cost or the peak cost depending on the situation, right? So obviously, minimizing the loss revenue is one of the priorities, but bear in mind that the objective is not, oh, SRE is very cool, we need to implement that. No, that's not the mindset. That should not be the objective. Something is cool, you should not implement and adopt something because it is cool and because it is evolving. Now, we are going to talk about, I think some of you raised how to implement SRE, right? As per the industry standards, there are standard adoption uh, mechanism for SRE, and the standards are, I mean, you can see it starts from a consulting mode and goes to a full SRE mode, right? How do organizations adopt that? So if you see, lot of organizations start this adoption in a consulting mode. So consulting mode is uh, uh, a method of SRE adoption, wherein you will have some experts onboarded, some consultants onboarded from some consultancies like Accenture, or like from PwC, or from Sapient, or any of the top 10 consultancies, right? There will be some experts, consultants, and they will provide guidance and advice to the existing service delivery team within the organization, right? That's how the model is. But if you see in this model, there is no hands-on involvement in delivery. So there is no kind of shared responsibility, and the consultants, they do not do any on-call activities, right? So that is the very first level of SRE adoption. After that, the next level we call it as embedded. So in the embedded model, the SRE specialists are more involved in what service delivery team actually does. They will co-work with the SRE team, often the development activities. KT knowledge transfer then passes over to the team, and then it becomes, over a period of time, it becomes a shared responsibility. And then the SRE specialist, they pick up the initial on-call activities, but over time, everyone takes their turn to provide the on-call support. So that's, you can see the evolution, how exactly it is evolving from consulting to embedded. Now, after embedded, the next one is SRE adoption at a platform level. And in this model, the SRE team takes care of the underlying platform, whether it is cloud or whether it is on-prem, that uh, does not matter. Okay, so they take care of the underlying platform on which the application or the suite of application runs, along with typically owning the tooling stack that is used for SRE automation. Okay, so here the SRE team owns the production platform and sometimes the pre-production platform as well, and they often provide the first level support and the on-call support for any of the activities associated with either pre-production or with production. Yeah. So they may seek to share the responsibility, but it is only up to a certain level, uh, maybe the platform components, but usually they do not overlap. Uh, they do not develop enough knowledge uh, of the service to move to a full shared responsibility model. So the responsibility model is still partially shared, not fully shared. So that is the evolution from embedded to platform. And now from platform, the next level is called as slice and dice. So slice and dice model is, as you can see, the name itself says, right? SRE owns some of the elements, and the service delivery team, the existing service delivery team, they own some of the elements, right? The slice can include application and infrastructure components, uh, or I mean, it needs to be agreed between both teams what they are slicing and dicing amongst each other. So this model is pretty much similar to the platform model, but the only difference is that it allows the SRE team to develop a more in-depth knowledge and understanding of the wider services, allowing some shared responsibility to develop. On-call responsibility is still something which is divided. Okay. Last but not the least, if the organization goes into a full SRE adoption, then going full SRE, it involves all the team members embracing SRE practices. Everyone is going on call. The shared responsibility for site reliability from day one and backlogs that prioritize reliability is on par with whatever new features are being developed. So this is the full SRE adoption. There is a very important concept. We call it as the true north vision. And again, this concept arose from a production company from Toyota, right? And basically, it is um, the leadership vision for SRE adoption in any of the organizations should always be true north vision. True north means what? right? If you visualize uh, a number of leaders in an organization, if they have to embrace SRE, and a number of employees in an organization, so there needs to be a explicit, a smart goal defined that yes, as a part of SRE, this is what our strategy for SLO, SLI, this is what our strategy for monitoring, this is what our strategy is for tooling automation. It has to be homogeneous across, and everyone should start working for achieving that vision in the same direction. That is what true north is. It should not be that you have got, let us say, a retail banking team, you have got a commercial banking team, you have got a mortgages team, and every team is working in, one team is working in east, one is working in west, one is working in north. No, that doesn't work. When you have to embrace SRE at an organization level, right, your vision has to be very clear, and across the organization, all the directorates, all the business
Puppy.
units, all the
I
employees
kiss you,
working in the
puppy.
business unit should be focusing to achieve that unidirectional flow. They have a unidirectional visualization of the end state that they want to reach. That is what the true north vision is. Okay. Now, very because of
Take.
the known reasons. Incident response on call. Being on call is a critical duty that operations and engineering team must undertake. If you remember, we talked about the 50-50 ratio, right? So 50% of the time on call, on support, on operations, 50% of the time on development activities, right? So obviously, we all know what happens on call. There is nothing new.
రిషు అది బ్రేక్ అయింది నీకు నొస్తాయి మళ్ళా
On calls by
మళ్ళీ బ్రేక్
numbers,
అయిపోతాయి
how much downtime is allowed for service users? I
నీకు
mean,
మళ్ళీ
we
పెయిన్
talked
వస్తాయి
about
ఎంత డ్రైవ్
three
ఎక్కితే
nines, 4 nines, and 5 nines. So basically, 3 nines equates to, if you see, it gives you how much downtime per year, per quarter, per month, per week, per day, per hour, right? That it means. Okay. On call again, yeah, this is for an effective on call. There are not much changes. Yes, obviously we need to have allocated individuals, we need to provide them with suitable devices. There needs to be a very good alerting mechanism on their devices. There needs to be documented procedures on what needs to be followed for what flavors of incidents that are being raised, and obviously there need to be blameless post-mortem that we talked about. Automation to replace on call. I mean, if you remember, I told you one example wherein we are talking about self-healing nature, right? That example of database connection pool getting exhausted and self-healing automatically being taken care by Dynatrace by communicating to the database using the service user account and increasing the connection pool. So that's one typical very live example that I have seen it, uh, wherein you can clearly see that the incident management here doesn't need any person in between. You don't need an incident management team, right? Even the incident management team will not have any awareness of that something like this happened yesterday and it was implicitly taken care of. So similar to that, uh, there can be a lot of incidents that can be managed in a self-healing way, but it is not that simple. I mean, obviously, uh, before building in self-healing capability into the system, there needs to be a lot of analysis, and that analysis can be done only when we have proper observability built in for the entire stack. So someone or a suite of team would need to really deeply analyze the way in which the application has been consumed since past 6 months or 1 year, how exactly it behaved and what were the failure points, what were the past flavor of incidents, and using those past flavor of incidents, an analysis needs to be done that what out of those incidents can be really automated in a way that the system automatically takes care of it without any manual intervention. Blameless postmortem. So failure happens. This is a foregone conclusion when working with complex system. Nothing new. Failure is bound to happen. Why we need to have a blameless post-mortem? Because if we don't have that in our organization, then slowly and steadily the culture in the organization it it gets deteriorated, right? We are talking about, if you see the Western culture of organization, we are talking about being a generative organization, right? So if we want to be a generative organization, then obviously we need to adopt the blameless postmortem. If we are not adopting that, then we will always be in a kind of bureaucratic organization. And it helps us, if we see it positively from a learning perspective, then it helps us to identify the root cause. It helps us to re-engineering the system so that the incident which happened, right, doesn't happen in near future, right? That is the main reason or the objective. It allows us to build in the monitoring capability in such a way that the incident that happened, right, it is implicitly allowing us to build in some self healing capabilities depending on the feasibility analysis. So yes, it is basically whatever incident management process we follow, but in with a changed mindset. What actions are taken at what point of time, what effects are observed, what are the expectations, what are the assumptions. Everything has to be well structured and documented. Blameless postmortem doesn't mean that, okay, fine, we are just leaving it out of generosity, right? No, needs to be a disciplined way uh, to deal with that postmortem. There needs to be a professional way, there needs to be a well documented procedure, uh, so that the learnings can be well documented, the outcome can be well documented, the solution can be well documented. We talked about this. It's a repetition again, the Western model, creating a safe environment. Have you ever heard of uh, safety culture? No. Okay. So safety culture is basically a culture. Again, another. mm there was a gentleman called Sidney Decker. So he came up with this, and according to him, I mean, the culture in an organization should uh, be such that no one is afraid of announcing any failures, right? They should feel themselves safe, that even if they fail, they are not at a risk of losing their employment, losing their job, losing their respect. And we should build in that level of safety culture in our organization. So regardless of what we discover, we understand and truly believe that everyone did their best job they could, given what they knew at that point of time, given their skills and abilities at that point of time, given the resources available and the situation at hand. So everyone always does their best, but if problems have to happen, they will happen. Right. The thing is, how it is perceived and how the person or the group of person involved learn from that situation and further improve their skills. Creating a safe environment needs to balance safety and accountability, as I say it, right? It is accountability, even though we are doing a blameless post-mortem, but yes, uh, accountability has to be there. It is not that uh, someone is doing mistakes after mistakes after mistakes, and there should not be a logic. I mean, it should not be a kind of blunder thing. Mistakes done for something which is brand new in nature, that is acceptable, but something which has already been there into the system, and if you are repeating blunders after blunders after blunders, then that is something which is not acceptable, right? We need to have that mindset as well. Changing the reaction of failure. What it says that assume the single cause is incompetence and scream at engineers to make them pay attention, right? And this is not the right way, right? Screaming is not the right way. Look at how incident actually happened. Treat the engineers involved with respect and learn from the event is the right way. Postmortem output, yeah. Detail of the incident, impact, trigger detection, resolution, participants, list of follow-up actions to mitigate future incidents, lessons learned. I mean, these are the very standard things which we now do as well as a part of incident management. If we really follow the best ITIL processes or ITSM processes, uh, SRE, just for your information, has inherited a lot of best practices from ITSM when we talk about release management or incidents management or deployment management, right? So a lot of ITSM and ITIL processes are being inherited by SRE. So don't get confused thinking that ITIL is different. ITIL is different because it's a different philosophy, but SRE adopts, complements, and supplements a lot of things from DevOps as well as from ITIL or ITSM. This is the case study for Sage Group. So I'll request the key concept here is incident management automation was what Sage focused on. And there was an appreciation that incidents are going to happen. So try and take away the admin pain to focus engineers on resolution. And as you can see, tooling really helped them. It's a very good example. Now we are talking about SRE and scale. Yesterday, if you remember, we talked that SRE is always related to something which we implement at a scale, wherein we are talking about large volumes, large customers, large concurrency, large set of infrastructure. Okay. Now, the key success factors is obviously we need a very big support from the executive management support and buy in from executive. We need funding. SRE is not cheap, it is expensive. We need a amazing relationship across the different business units, not only IT but business as well. When we talk about IT, the engineering capability, the product ownership capability, the operational capability, the security capability, all those capabilities needs to be having interwoven by very good relationship. Okay. And obviously the organization which is growing, right, which is at a scale. You can see it's written that organization that is not growing or scaling will not face the kinds of challenges that SRE is trying to solve. So the main objective of SRE is to solve the challenges at a scale. So if you are a small organization, you will not be able to benefit from SRE. So it is better you don't consider SRE until the time you really see that your business is in the expansion mode. So you can see that's how it's what is depicted in this particular graph, right? It is basically depicting the platform growth, the large volume of users as the time grows. Also, the growth in the number of tickets. So basically, the emphasis is that the challenge of a scale is always a good one. Stig Sorensen from Bloomberg. Uh, this is Bloomberg uh, scientist who came up with this. The challenge of a scale is always a good one. Through engineering solutions, SRE allows organization to scale their services at much greater rate than the scale of their organization. Yes, absolutely true. So SRE approaches now to platform growth. Let us briefly talk about that. So I think we have few more slides. Let us complete that. Then we can go for a lunch break, and then after that we can complete module 8, which is a very short, brief module. So from a platform perspective, whenever we talk about platform, basically we are talking about infrastructure, and the SRE approach for that, we talked about automation, infrastructure as a code. We talked about auto scaling, containerization, clustering, Kubernetes cluster, right? Adoption of cloud. Here they are also talking about the relational database services, RDS capabilities from cloud, or NoSQL database services from cloud like MongoDB, or non-structured database for dealing with those data which are not structured, or complete, which are semi-structured, those kind of databases. And as you can see, we have given more emphasis on this as a service, whether it is infra as a service, whether it is software as a service, platform as a service, or configuration as a service. So you could have sensed that there is a lot of emphasis on this acronym as a service, which generally is a flexibility that cloud service provider provides us. Uh, Shifting left, yes, no doubt at all. Shifting left is basically right from sprint zero, how a SRE incubates, how he educates the incubation of best practices, its implementation, its testing at regular intervals. Uh, that's what is the key to success for SRE. While reduction, we know about that. The only thing is, new thing is DRY. Remember this acronym DRY, which stands for don't repeat yourself, right? Yes, if you identify a new problem, a new solution, learn from it, implement solution for it, automate it if possible, but don't repeat it. This is Department of Work and Pension, which is UK organization, which takes care of the pension anything related to pension here in the UK. And this is the case story which says a major focus of SRE is the aspiration to never see the same issue twice. Often using automation as a resolution, we spend a large amount of time on reducing human labor, sharing knowledge among the team, and creating a blameless environment. Okay. Benefits is appropriate SLOs, reduced number of outages, proven scalability of digital services across 20 plus million users. So yes, again, you can see that he's talking about a scale. And the key thing is, we talked about try, do not repeat yourself. That is what he's saying, that never see the same issue twice. If you are seeing the same issue twice, it means that definitely you need to improve your SRE capabilities. Now, with that note, let us target this module 7 quiz, which is also not a problem, but I mean, the principles have to be adhered to, right? So the delivery mechanism doesn't matter, be it agile, be it waterfall, be it a scrum, be it scaled agile, or be it Kanban, doesn't matter, right? The thought processes have to go in to implement it. Is now um, a bit about, I mean, we talked about adhering or supplementing and complementing the best practices from ITIL and ITSM as well. That is something which is not new to SRE. SRE has no shame in saying that. It really encourages people to follow the best ITIL, ITSM practices. Now, in this diagram, as you can see, right, DevOps and Lean, Agile, ITSM, SRE. So the main objective here is to demonstrate the fact that SRE doesn't stand alone, right? It does interact with other frameworks, works, and it is highly complementary. It is highly complementary. Now, in terms of how exactly it interacts with Agile, let us just first talk about Agile, right? We are talking about the user stories and the backlogs right from sprint 0 or sprint 1. to think about reliability aspects, performance, capacity, scalability, network, resilience. All these aspects needs to be thought of if we are delivering in agile right from sprint zero. Product owners and the scrum master needs to get away from the traditional mentality of just implementing or developing the features, right? They need to think about other aspects, non-functional aspects as well, and they cannot think it on their own. That is why we need to have one SRE in each and every feature team in each and every sprint, so that the SRE can start advocating that. Similarly, DevOps and Lean, we saw, right? We saw the five pillars of DevOps, and we saw how exactly SRE supplements, complements, and overlaps with those. So nothing new into SRE and its complementation or supplementation with DevOps. Like DevOps, there is no one size fit all approach to site reliability engineering. What works for a company like Google or Facebook doesn't make sense for other companies. Effective SRE is not simply responding to incident quickly when they happen, but in building infrastructure, proper testing, improving the availability. I think we have talked about all these aspects many a times with multiple examples, right? But yes, one key thing is that it is not one size fits all, right? So it varies. The adoption of SRE, the implementation of SRE, mm, varies from company to company. It may vary from team to team, but yes, as long as we are adhering to the best practices, that is what is the need of the hour. Now here you can see the relationship between SRE and ITSM, and specifically ITIL4. If we see the processes that ITIL4 emphasizes, and I would not want you to know anything and everything, but here we are mainly, when we talk to ITSM, right? These are the key areas: the change model, the release process model, the testing model, the incident management model, problem management model, and the request model. So these are the various ITIL 4 uh, various chapters in that is prescribed for the various delivery models as per ITIL, right? The focal point is on these areas. So SRE says that whatever best practices are defined, and to be very honest, all the best practices that you can have for these areas of ITIL, IT infrastructure library or service management, right? Uh, these have been traditionally followed, and there is no harm, and all these best practices are really best practices, right? So let us not reinvent the wheel. If we can adopt those best practices from ITSM, and when we implement site reliability engineering in our organization, right, we can embed that as a part of our SRE. So ITSM process models support SRE. SRE helps compliance with ITSM by using engineering approach to remove the human factor from the equation. Automation leaves a documented and auditable trail. This not only increases confidence that ITSM rules aren't being ignored, but it also increases the deploy and release velocity by removing time to make human decisions. Mhm. Let us talk about the entire value stream right from the ideation phase until the operate phase, right? That is where you can see that SRE spans across all the phases, right from ideation until operate. And it not only is unidirectional, it is bidirectional. So when we implement SRE from the ideation phase, we are trying to adopt shift left, be it shift left in terms of design, in terms of architecting, in terms of testing, right? And Jane Grohl. Jane Grohl is the CEO for DevOps Institute, and she has been a ITSM practitioner for a very long time. Amazing knowledge she has got in ITSM. Watch this video, please, offline, and you can see the way she has described the correlation between ITIL 4 and SRE is really fantastic. Okay, now as I've been telling you, as we move on in next 4 to 5 years, we can see there are certain new trends in site reliability engineering, right? Failure is going to be the new normal if we really embrace SRE in a positive way. Automation as a service, cloud is going to be the king, and observability is going to be the key. Last but not the least, uh, network engineer, evolution of network reliability engineer. We will see certain new things, which to me it appears a bit funny, because there is nothing that I see new in this. For example, network reliability engineer, right? We are talking on the reliability aspects of network. So as of now, whoever are the network professionals, right, whoever are network engineers, right, the thought process of those network engineers, if it goes beyond, above and beyond what they have been traditionally doing, and they so once we reach to that phase, we may see that in our industry we have got a new job description or a new title evolving, called as network reliability engineer, right? And the emphasis is that professional area is going to be focusing mainly on how to ensure that, other than the day-to-day network IT implementations, we bring in the reliability aspects, right? Specific about monitoring observability of network as well. Similarly, we used to have database DBAs, right? But if you see historically, DBAs focal point was just database administration: how to create a database, how to delete a database, how to maintain a database, how to recover a database, how to do anything and everything from an administration perspective. But with the changed thought process, the vision is that DBAs would, the moment DBAs are in a position that they understand the performance, capacity, security, other non-functional aspects, and make it as a part of day-to-day administration activities, focus more on monitoring, alerting of databases, bring in, build in self-healing capabilities in the databases. So that's going to bring in the evolution, and we may call it as database reliability engineer, DBRE. Okay. Again, customer reliability engineer, right? Our incident management team, which we call it as now. So in near future, in next 2 to 3 4 5 years, right, we may see the evolution of customer reliability engineer, which basically will be, I mean, if you see, underlying is net incident management, but yes, leveraging the best SRE practices, knowing about SRE, understanding of some automation, how to leverage automation for incident management and all. So this is going to be another evolution, followed by heritage reliability engineer. I mean, most of the colleagues or professionals who are currently mainframe IBM Z series or Unisys mainframe administrators, right? Those systems are still going to exist. I mean, maybe we don't know, they will vanish after 5, 10, 20 years. We have no idea, or especially the core banking system are built on those legacy platforms. So we may see that the evolution of those people who are mainframe professionals, right, who are working on mainframes now, and let's say as a part of re-engineering, those mainframe systems have to be re-engineered into some modern platforms, modern databases, right? Obviously their inputs, their knowledge, their experience will be required. So that is where they are going to be really instrumental. Okay. So even legacy applications have the opportunity to benefit from the new approach. It's not like mm, mainframe Z series or Unisys mainframes are going to be obsolete. Observe and learn. I believe that in next 3 years, all three of those categories, which is APM, application performance management, monitoring metrics, logs, and possibly others, are likely to cease to exist. We talked about that, if you remember, and all these are going to be clubbed under one heading, which is called as observability. And this is